Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera to all the student. Okay, today we are going to learn about diode application, and now we are going to focus on the new subtopic, which is clamper. So what is the function of clamper? As you can see, to clamp or shift a signal to a different DC level. So circuit consists of C, D and R. C stands for capacitor, D is the diode, and R is the resistor. So this is the type of negative clamper. As you can see here, for a negative clamper, the polarity negative is opposite to the VDC, negative terminal for VDC. So now we go on to the analysis of negative clamper. During positive half cycle, there will be 3 steps that you need to understand. First, find the polarity of VC. The second step is to determine Vout using Kirchhoff voltage law at the output. So for the second step, during positive cycle, this is the loop for positive cycle, the blue color loop. This is the output loop. So in order to determine Vout, we have to refer to the red line, red arrow line here. So from here you can get the equation, which is Vout minus Vd plus Vdc equals to 0. Some of you can use the polarity for current entering the node, or maybe current entering the terminal. For example, this the equation might be different as in the node here. So it depends on your understanding. You can also write down minus Vout plus Vd and minus Vdc equals to 0. Still will get the same answer. So here, as you can see, Vout is equal to 0.7 minus 5, and it will be equal to minus 4.3 volt. In step 3, you need to determine the value of Vc. So you have to refer to the blue color arrow here, the blue color loop. So the equation is Vin minus Vc minus Vout equals to 0. So Vin minus Vc minus Vout equals to 0. Okay. For your information, output voltage across terminal resistor R is actually equal to the output. It is actually equal to the voltage across this terminal. Alright, so Vc equals to 24.3 volt. That is for positive half cycle. Now we go on to the negative half cycle. So during negative half cycle, as you can see in the figure, the diode will be off. So the current will flow through resistor R and pass through the capacitor. First step is to determine Vout using KVL at input. So here, as you can see, the equation will be Vin plus Vout plus Vc equals to 0. And after you have substitute all the values in the equation, so you will get minus 20, minus 24.3, and this will be equal to minus 44.3 volt. So here are the output and also input signal. This is the input and this is the output signal generated from the analysis. Now we go on to the positive clamper. So as you can see here, the difference between negative and positive clamper is that the polarity of diode plus will be opposite with the positive terminal for VDC compared to the negative clamper, minus at the diode, the polarity will opposite with the minus sign of the VDC. Okay, so during negative half cycle, because diode on at this cycle, so there will be 3 steps also in the analysis. So the first one is find the polarity of VC. So this is the polarity of VC. And step 2 is to determine Vout using KVL at output. So here, as you can see, during negative half cycle, you will get the equation Vout plus Vd minus VDC equals to 0. The loop is actually here. You can see by looking at the arrow cursor. So Vout plus Vd minus VDC equals to 0. Remember that some of you may use different method where you can choose the current entering the node or terminal to find the equation. For example, here, if you choose current entering the node or terminal, the equation will be minus Vout minus Vd and plus VDC equals to 0. So it depends on you. Okay, so here Vout will be equal to 5 minus 0.7 volt. This is actually the value after you have substitute the value of diode and also VDC. Here you can get the output voltage equals to 4.3 volt. Step 3 is to determine VC using KVL at input. So the same concept that you use as in the negative clamper analysis. So Vin plus VDC minus Vd minus Vc equals to 0. So this is by referring to the blue arrow loop here. You will get the equation Vin plus VDC minus Vd minus Vc equals to 0. So by substituting all the value, you will get Vc equals to 24.3 volt. This is during the negative half cycle. So continue during the positive half cycle. The first step is to find the polarity of V out. So here the equation is V in. Okay, V in plus VC plus V out equals to 0. Remember, this is positive half cycle, so you have to refer to the blue arrow line here. So the loop will be like this. Okay, so minus if you are using different method, for example current entering the terminal, so the equation will be minus V in minus VC plus V out equals to 0. Okay, this equation comes due to the open circuit condition at the diode terminal. So from here out, the output during positive half cycle is 44.3 volt. So you have to combine the output from the negative half cycle and also from the positive half cycle. This is the final output. These are the output. I'm sorry, this is the these are the signal. The first one is the input signal and the second one is the output signal. So okay, this is the example of how to design a clamper. So the assignment for you guys is to understand the concept of how to design a clamper by referring to this page that is at the page 45 in your notes. So I think I think that is all for today. So remember to understand the example here, how to design a clamper, because I'm going to ask you your feedback in the next class. So this is the summary of clamper circuit, as you can see in the notes here. So that is all. Thank you very much. Remember your assignment. Okay guys, Assalamualaikum and salam sejahtera. Bye.